Hello. This lesson will cover the creation of properties for materials and scantlings within Maestro. To do materials, we pick the Materials button, shown here, Materials. And here's the values used within Maestro. There's no magic here. This is just standard material properties. We have the Young's modulus, Poisson ratio, density in the units you've chosen. The units can go back and forth. You can start in inches, pounds, shift to metric, and then come back again. It doesn't matter. Everything is stored in the background in the Maestro file within metric. And then it does the calculations on the fly and then displays the results in the units you wish. There's density, yield stress, ultimate tensile strength. For aluminum, what is the yield strength in the heat affected zone? That is important for aluminum structures because it is looking at that in two places. One is at the root of the weld between a beam and a stiffener, or rather, a beam and the plate, and also then the plate stress, where you're welding the plates together. If you are using extruded panels, the beam properties will not use the heat affected zone because there is no heat affected zone for the stiffeners. It's part of the extrusion. But the plate that you're using will have a heat affected zone. So you would have for extruded shapes, aluminum, you would have two different properties. The extruded stiffener and then the extruded plate, each with different value for the heat affected zone. To put in a new material, I'm going, as with all Maestro things, menus, if you push the ID button, you increment to the new value. I'm going to put in new steel is the name, and I'm going to hit create. Now, it used the values that were there before. Now, I'm going to change, let's say, the yield stress to 34,000, and the ultimate strength I'm going to make 100,000. I'm making these numbers up. I now modify, not create, because I've already created the material. Now I'm modifying it, modifying the values. If I saw there was a mistake, go in, change that to 90,000. Modify it. If I made a mistake completely and I just don't want this material anymore, delete it. It's gone, and I close that value. So once again, to create a new material, to look at materials, you use the material menu, you enter the values, you either create if it's new, or you modify if you're modifying an existing structure. Now we're going to move on to beams, plate, and so forth, putting in the scantlings. To put in the properties of beams, plates, and so forth, you go to the Properties menu, shown here. And what you have are several tabs for plate, beam, rod, spring. The behavior for all of these of inputting values is the same as it is throughout Maestro. There's a name, there's a number. The names must be unique. ID numbers must be unique. This particular one, I've got property number 7, it's a copy. Let's look at 375 high strength steel, or 375 high strength steel. It's property number 3, shown here. It's the material, so I put it in. I get to choose the material. You put in the thickness, you put the thickness in, and the units that you're using for this particular model. This is an inch-pound-seconds model. There's the thickness in inches. But let's say that I want to put in this 3/8 inch plate, but I wish to review the rest of the model in metric. That is entirely possible. Here I am in those units. I'm going to close this. I'm going to go to File, Units. I'm going to shift units to newtons millimeters, apply it. Okay. I'm going to go back and look at that material property. Excuse me, not the material property, the plate property. Remember I said it was 375 HSS. Well, it's 9.525 millimeters thick, which is the correct thing. So the value, it's called 3/8, but it's now 9.5 millimeters thick. Maestro always keeps everything in metric in the background. Now I want to shift. I'm going to go back to my inches and pounds. File, Units. Go back to IPS. Apply. Okay. There I am back in, for me, an American, my good old-fashioned inches, pounds, seconds. So, putting in plate is pretty simple. Beams, however, are slightly different. Unlike Nastran, ANSYS, or any other general purpose FE code, beams in Maestro are put in using the scantlings. We're not putting in area and moment of inertia. We're defining the heights and the thicknesses of the webs and the flange. Notice I said the height of the web, not the height of the beam, the height of the web. Before I get started, I'm going to bring up part of the Maestro help file, which you can get to by pushing help and opening up the Maestro help file. I already have it open. Okay, so as you can see here, here's a T stiffener. When we put in the breadth of the flange in Maestro, we're talking about, yes, the breadth of the flange. And yes, the thickness of the flange, dimension 3. Thickness of the web, as described, it's the thickness of the web. But the height of the web is being defined, not the height of the stiffener. Do not put in the height of the stiffener for the height of the web. You are putting in the actual height of the web. This is critical to be used, because when we look at a Maestro, when we're looking at various failure modes, including buckling of webs, we have to know what the height of the web is. So, closing this, you go to put in the beams. Here's the various, there's a 4x4 by 5 inch or 5 pound T stiffener. You put in the thickness, the height, the height of the web thickness, flange of the web, flange thickness. All these are out of the catalogs. You define whether or not this is a stiffener, a frame, or a girder. This becomes important if you go to a more fine mesh model called level 2, where stiffeners are modeled explicitly. At that point, Maestro needs to know, is this a stiffener or a frame for failure modes as it assembles what are called the evaluation patches. You also define, what is this? Is this a T, a bar, a bulb, an angle, so forth? You're just defining what this shape is, because different failure modes, different scantlings have different failure modes. Enter all this in, and the standard of create, modify, delete. To create a new stiffener or a new plate, as with all Maestro menus, when you're incrementing a new plate, a new beam, a new stiffener, layout, whatever, you hit ID, would like to copy an existing. I'm going to say no. Now I've got bar property number 25. You put in the name, new beam, I'm going to call it. I put in the web height, I'm going to call it 10 inches. The web thickness, I'm going to just say it's 0.25. The flange width, I'm going to make this up, it's 6. And the flange thickness, 0.375. It is a T. And I'm going to call this new beam frame, by the way. And it's going to be a frame. I hit create. So when I go look at the bottom of this list, there will be new beam frame with those properties. Now previously I had said that we put in the scantlings of Maestro properties, for our beams and so forth. But when you get to a rod, and rods are used, they are a non-bending element, strictly a rod. You can put in either the principal dimensions, or you can put in the integrated characteristics. In other words, the section area, moment of inertia. It's entirely up to you. So, if it's a rod, you would put in the outside diameter, the wall thickness. I'm going to pick here 6-inch schedule 40. These are made up numbers. I'm calling it 6 inches outside, wall thickness of 0.25. You pick the material and so forth. You just put those values in. It is your choice if you wish to put in defining the outside diameter and the thickness, or you can just put in the area, the moment of inertia. That is entirely your choice. This concludes the lesson for the basics of putting in material properties and stiffener plate properties within Maestro. For more advanced topics or further research, go to Maestro Help here. Opens it up, and you can then look in geometry, finite element modeling, defining stiffener layouts, defining materials and properties, walk through, get off the full description. Thank you.